Hi there, my name is Oliver. I'm going to be talking about the Gale-Shapley algorithm today, which is a solution to the stable matching problem. With stable matching problem is when you have two groups of equal size and they need to be paired up. Each member of each group has a preference of who they would prefer to be paired with, and you can think of multiple scenarios in which that might happen. The one I'm going to be using today is taking dogs for a walk. So the Gale-Shapley algorithm has, as inputs, it has two sets, A and B, and then each element has a preference list of the other set, of all the elements in the other set. And so you have two groups, one is doing the proposing and one is being proposed to, while there exists some element in the proposing group that is unmatched and hasn't proposed to every other element in the other set yet. It'll propose to the next element on its list that hasn't rejected it yet. And if that element doesn't have a partner yet, they'll pair up and we'll move on to the next element that isn't paired. If that first element does have a partner, but they prefer this new one to the one they currently have, they'll swap. And if they do prefer their current partner, they'll reject this first A. And this A will remain unmatched, and then it'll go through and it'll go to the next one on its list, and it just kind of goes down. And so that will continue until everyone is matched. Okay, so as an example, we have people who are asking dogs if they want to go for a walk with them. The people are Barack, Kamala, and Hillary. The dogs are Fang, Lassie, and Clifford. And their preferences, this is their first choice, second choice, third choice for all of them. And so starting with the algorithm, the first one that isn't matched, so Barack asks Clifford, do you want to go for a walk? And Clifford says yes, because he doesn't have a partner yet. So they are tentatively matched. Kamala asks Fang, hey, you want to go for a walk? And Fang doesn't have a partner, so he agrees, even though it's his last choice. Something's better than nothing. Hillary then proposes to Fang, and Fang, who's standing by Kamala, says, well, yeah, I want to go for a walk with you more than I want to go for a walk with her. And so he moves away from Kamala and goes and stands by Hillary. And so Kamala was rejected by Fang. So once through the algorithm, and we still have someone who's unmatched. So Kamala proposes to the next one on her list, and that's Lassie. And Lassie doesn't have a partner yet, so accepts. And then everybody has a partner. There's no one who is unmatched. And so the algorithm terminates, and it returns this stable matching. So it'll be Barack Clifford, Kamala Lassie, and Hillary Fang. So as far as complexity goes for the Gale-Shapley algorithm, it requires a big O of n squared time complexity, n being the size of A and the size of B. Since they're the same size, n is equal to the size of either of them. Because in the worst case, each member of the proposing group will need to propose to every single one, and that ends up being n squared. As far as space complexity goes, it's similar, so you need to store the preference list for each group, and it ends up being 2n squared, which big O of n squared for space complexity as well. So to clarify what stability means a little bit more, say for example that in some matching you had Fang and Kamala paired together, Kamala and Fang, and Lassie and Hillary paired together. Lassie and Hillary. Lassie and Hillary. So you can see that if in this matching it's unstable because Fang and Hillary prefer each other over their current partners. So Fang would rather be with Hillary than Kamala, and Hillary would rather be with Fang than Lassie. And so that pairing is unstable. And a stable matching is one in which there are no unstable pairings. One of the most well-known implementations of the Gale-Shapley algorithm is the residency matching for med students. They use a variation of the Gale-Shapley algorithm, modification of it. And they actually, originally it was a hospital proposing system. Of all the possible stable matchings, it was giving the hospitals their best one and the students their worst one. It was still a stable matching, but it was their worst pairing for each student of all the stable matchings. So they switched it in the late 90s to be a student proposing method, and it's been that way ever since. So that's the Gale-Shapley algorithm. I hope you enjoyed it. Thank you for your time, and I hope you have a great day. Bye now.